All right, let's get back to chapter 3. Where we left off, we were starting to deal with some of the more complex types of problems that you will encounter when looking at applying the units and prefixes. So in this application then, what we're looking at is a circuit where we have two resistors in parallel. And so this is a little advanced for what you're going to see initially. Usually we start with series, but this one is nice because it has some reciprocal values here that we can deal with. So we're looking at treating two resistors that are connected in parallel. The first one is 27 k ohms, which is 27,000 ohms. And the second resistor is 18 k ohms, or 18,000 ohms. They want us to find the total conductance. Now, conductance is the inverse, or the reciprocal, of resistance. So that's why we've got this 1 over situation here. And the total resistance, RT. So they want us to find the reciprocal of resistance and the resistance. And we're going to round those answers off to 3 places. So the mathematical relationship for a conductance and resistance is that's the reciprocal relationship. RT, or R total, is equal 1 over conductance total. And the total then will be the sum of the conductance of those two resistors, so G1 and G2. So if we're going to find the resistance is the reciprocal relationship of G1 and G2, which is 1 over R1 and 1 over R2. So if we create then the mathematical relationship, we have the resistance total is equal to 1 over the sum of the two conductances, which is equal to 1 over the reciprocal of the resistance 1 and resistance 2 summed together. So using that expression now, what we need to do is start putting our values in here and start calculating. So since we were not given the conductance, we need to use the resistance values. So if we plug in 27 k ohms and 18 k ohms into R1 and R2, we have this relationship. So what we need to do is just start on the values in the numerators. So if we take 1 over 27,000 ohms and 1 over 18,000 ohms, and we just use the pure values of those, we can sum them. And what we get is, if you look up here, we get the conductances. So we went from ohms, which is resistance, to a value which is called a Siemens, S, for the conductance. So now if I sum the combined value of those two resistances inverted, I get 37 microsiemens plus 55.6 microsiemens, which gives me a total of the conductance of 92.6 microsiemens. So that's the total conductance. Now what I need to do is invert that, and I get 18.8 thousand, or k ohms. So I've calculated to this step the conductance in the denominator, and then when I inverted it, I got the resistance numerator. So these are the kinds of mathematical expressions that this course is preparing you for. This course is preparing you to be able to deal with applied mathematics. You have to understand the mathematics before you can do these applications, but we're going to build on that. And you're going to see this for the next 15 weeks. And then by the time you get to first semester DC for electronics, this stuff will be second nature to you, but you just have to work with it. So in the systems of measurements, which we must become familiar with as electronic engineering techs, the metric system and the English system. Why the English system? Because that's the basis of what we use. But metrics is what we use in electronic engineering. The metric system is based on the international system of weights and measures. The meter for linear measurement and the gram for mass or weight. Okay? One thing to keep in mind, some people ask, well, what's the difference between mass and weight? Well, you'll learn when you take the first semester physics course that it's gravity that gives mass weight. So that basically that's telling you there's a product. I have to multiply gravity times the mass, and what I get as that product is the weight. In the English system, we use the yard for linear measurement and the pound for weight. So this is doing a comparison. You have to be able to do some conversions, which we will get to as we go along, but this gives you a quick understanding of metrics versus the English system. So in electronics, we use the international system, or we call it the SI quantities. Those SI quantities are, by definition, voltage, current, resistance, conductance, and capacitance. For voltage, we use volts. For current, we use the ampere. For resistance, we use ohms. For conductance, we use Siemens. And for capacitance, which we'll get to, we use the farad. Are there others? Yeah, there are lots of others, but this just gives you an idea. So the SI quantities are volts, amps, ohms, Siemens, and farads that we will use at this point. Now, how do we apply these metrics to some of these other weights and measures and conversions? Well, let's take a look at what 1 millimeter is. One tiny, tiny little length of measure. 1 millimeter is 10 to the minus third meters, or as we've seen, 0.001 meters. Pretty small. If you're not familiar with what a millimeter is, pull out your ruler and flip it to the edge that has meters and centimeters and millimeters, and you'll see what a millimeter is. Tiny, tiny little distance. A centimeter is 10 to the minus 2. A kilometer, though, on the other side, notice we have a positive exponent, is 1,000 meters. Okay? So on the British side or the English side, we say 12 inches equals 1 foot. 3 feet equals 1 yard. 5,280 feet is equal to 1,670 yards, which equals 1 mile. Now, are we going to use those last three in electronics? Not necessarily. You will use them in your physics course, though. So we must be able to convert from one system to another. Again, the calculator that I recommended for you, that Casio calculator, has a whole library. There's 40 different conversions in that calculator that will do this automatically for you. So you don't have to fat finger it in every time. So if you needed to convert to inches to centimeters, yards to meters, miles to kilometers, centimeters to inches, meters to inches, meters to yards, kilometers to miles. These are the conversions. Okay, if you don't have a calculator, if you don't have that Casio calculator, and maybe you have a programmable one, you can put these in there. Otherwise, you're going to have to get out your notebook and keep track of these measures as you go along. So, Chapter 3 got us through all of those things that were related to units and prefixes. We were able to take a look at each of the areas, do some conversions, start applying those prefixes, looked at the application and the systems of measurement. So now we've gotten through 3 chapters. We'll hit Chapter 4 next time.